Hi students, welcome to another video of our series previous year questions of chemistry 2024. Right, so we have seen many other videos of other chapters like atomic structure, and we have seen the videos of chemical bonding. Now today I am coming with the video of the chapter chemical equilibrium. Right, chemical equilibrium. So I'm so sure that you have studied this chapter and you are very familiar with concepts. Right, at first you may have some kind of doubt regarding this particular chapter because the concept is new to you, but after studying that chapter I am very sure that you are excited to do the questions because the concepts are very easy. Right, the formula and all the things related to it is very easy to understand and solve. So these questions are actually the questions which came for 2024 JEE Mains, and the good news is that it's very simple. These particular questions are very simple. It's just reading the question and applying the formula. So we will start further without any delay. Right, so we will move to the first question. Here, what is the question? For the reaction N2O4 giving you 2NO2, Kp is 0.492 atm and at 300 Kelvin. Kc for the reaction at same temperature is. So the first question is actually to find out the equilibrium constant Kc. Right. So here we know that we have a traditional, like a normal method of finding Kc. Here we should not go for that. Here we have to bring the relation between Kc and Kp. So here what is that relation? You know that Kp is equal to Kc into RT raised to delta N. Actually, this is the equation that we have to use to find the value of Kc, right? Because they have given Kp, the temperature T is there, and you know that R, universal gas constant value, is also given. So the unknown value to find this particular Kc is delta N. What is that? Delta N. So we know that delta Ng, right? Delta Ng is equal to what? Np minus Nr, number of moles of products minus number of moles of reactants. So in this equation, you know that number of moles of products 2, number of moles of reactants 1, right? 2 minus 1, you are having 1. So delta Ng is 1. So we can find out the value of Kc now because all other values are known, right? So we can easily find out the value of Kc. So we will just substitute the values. We are having Kp as 0.492 equal to what is Kc we have to find out. Then we have R. What is R? 0.082 into what is temperature? 300. And you know that our delta Ng is 1. So here we will just rearrange this particular equation. Then we will get Kc equal to 0.592, what is that? atm, atmosphere, by 0.082 L liter atmosphere per mole per Kelvin. Then we have 300 Kelvin. Right. So here, this is the thing. We have just rearranged the equation and we know all other values apart from Kc. Right. Now we can easily find out the value of Kc, and I'm just leaving the calculation to you people, and at last here you will be getting an answer of 2 into 10 raised to minus 2. So here the answer is that 2. Right. Here you will be getting this particular answer 2. So what is the thing you have to be careful in this particular question? Here we have to remember the formula Kp is equal to Kc into RT raised to delta N. And from the given equation, chemical reaction, we have to find the value of delta N. After that, you just substitute these values and you will be getting the answer. So I hope this was an easy question for you. Right. Now we will move to the next question. Right. The following concentrations were observed at 500 Kelvin for the formation of NH3 from N2 and H2. At equilibrium, the particular concentration of N2, NH3 and H2 is given. We have to find out equilibrium constant, right? So it is the obvious question that we are expecting from this chapter, right? To finding out Kc from the given concentration. So if you solve this problem, you are getting 4 marks, right? So this is very simple question and we will solve it fast. So you know that first of all we will write the chemical reaction. So this is what Haber process, the production of ammonia, right? So you know that N2 plus, right, N2 is gas, 3H2 again gas will be giving you 2NH3, right? So you will be very familiar with this particular Haber process throughout this chapter. We are having this particular example, right? So here, what we have to do, we have to write the equilibrium constant Kc. So you know that the concentration of products. So here, NH3 is the product and the stoichiometric coefficient is 2. So we have to raise it with 2. Now N2 and H2. So this is actually the formula and raised to 3, right? We are having 3 moles of H2. So this is the formula. Now we just substitute the values. NH3. What is the value of NH3? It is 1.5 into 10 raised to minus 2. And it is raised to 2. And N2, what is the concentration of N2? 2 into 10 raised to minus 2. Then the concentration of H2. 3 into 10 raised to minus 2, the whole raised to 3, right? Now I will just solve the next step. So 1.5 the whole square into 10 raised to minus 4. Then we are having 2 into 10 raised to minus 2 and we are having 3 raised to 3. What is that? 27. 27 into 10 raised to minus 4. So this will be your calculation to solve. So after solving the calculation, we will be getting the value for 70, right? So in order to just move forward, I am skipping that calculation part. I know definitely you can do this calculation. So we have reached this calculation by just putting the concentration of this particular reactants and products, and you know that how to find out Kc if this particular concentration of reactants and products are given, right? So it was a very easy question. Now we will move to the next one, right? So by seeing the question, you may have a kind of doubt whether it is a tough one, but my dear students, just see, they are asking us to find Kc of this particular chemical reaction and the same formula that we have used. What is that Kc? Kc is actually the concentration of products raised to the stoichiometric coefficient divided by concentration of reactants raised to the stoichiometric coefficient. So from this particular chemical reaction, just write Kc. So we know that here Fe3 plus Cn minus giving you FeCN2 plus. So here you have the product, here you have the reactants. So what will be Kc? Obviously Kc, the concentration of the product. So it is what? FeSCN2 plus divided by Fe3 plus and SCN minus, right? Such an easy question. So what will be your answer? The first one, right? The first one will be your answer, right? So if you make it right, you are getting 4 marks. That's what I said. This is a easy chapter, right? Now we will be moving to the next question. Here you have to just think more in this particular question. So you can see this particular reaction, A giving you B plus C by 2, a reversible reaction. The correct relationship between Kp, alpha and equilibrium pressure P is. So we are actually concerned with equilibrium pressure, and at that particular condition, what is the relationship between Kp and alpha, right? So Kp is what? It is actually equilibrium constant at pressure, right? At particular, like in terms of partial pressure, we are writing equilibrium constant, that is Kp. Now we will just see how this particular concentration of these reactants are changing. A gas, gaseous reactant giving you B, which is gaseous product, and C by 2, which is gaseous product. Now, initially, you know, it will be 1. The concentration is 1. Here, you will be having no concentration. Now, at equilibrium, right, at equilibrium, you know that it will become 1 minus alpha, right? So, that is what dissociation constant, right? Degree of, not constant, degree of dissociation. Then here it will be what? Alpha. Here it is what? Alpha by 2. Now, you have to be very careful. Here, certain steps are told by me. You should be very particular about that. Now, you know that these are actually the concentration at equilibrium. Concentration at equilibrium. So, here, we can say that total number of molecules, here is what? The sum of all this, 1 minus alpha plus alpha by 2. So, alpha and alpha will be going, then you will be having 1 plus alpha by 2. 1 plus alpha by 2. Now, I am just writing the mole fraction of each reactant and product, right? So, here mole fraction of A, mole fraction of A. So, here I can write what is the mole fraction of A? It will be 1 minus alpha by 1 plus alpha by 2. What is that? Number of moles by total number of moles. So, mole fraction of B. Mole fraction of B will be what? Alpha by 1 plus alpha by 2. Now, mole fraction of C, what will be that? It is alpha by 2 by 1 plus alpha by 2. I hope this is clear for you, because this particular step is useful after writing our Kp. So, I'm just writing at the top. Hope you don't mind. So, what is Kp? Kp is here. In this particular reaction, Kp is partial pressure of A. Right, partial pressure of A. I'm sorry. First we have to write the products, right? So, here, what is the product? B and C. So, Kp, we can write Kp is equal to, I will do one thing. I will just erase this particular part, because we need only this particular mole fraction. I hope this particular starting is clear for you. We don't need that. I will write at that place, right? So, here you can see Kp. What is Kp for this particular reaction? This partial pressure of B into partial pressure of C raised to 1 by 2 divided by partial pressure of A. Now, we have studied a particular formula. Partial pressure is equal to what? Mole fraction into total pressure, right? Total pressure. So, we are going to apply this particular formula in this particular equation. So, I can write here Pb, right? Pb. So, what is Pb's mole fraction? I can write now Kp is equal to, Pb's mole fraction is alpha divided by 1 plus alpha by 2 into total pressure means P. Now, Pc, what is Pc? Like mole fraction of C is what? Alpha by 2 divided by 1 plus alpha by 2 into P, the whole raised to 1 by 2. Right. Now, the mole fraction of this particular, which is a downside, we are having A. Mole fraction of A, 1 minus alpha divided by 1 plus alpha by 2 into P. Right. So I hope what I have did in this particular step, I have used this particular partial pressure. We are having partial pressure PB, PC, PA. I can substitute it as what? Mole fraction into total pressure. So mole fraction already I have written. This 3 ABC mole fraction I have written into total pressure. Total pressure I have taken as P, right? So each values I have substitute based on that particular formula. Mole fraction into total pressure, mole fraction into total pressure, mole fraction into total pressure, mole fraction into total pressure. Now it is simplification. So I can simplify this 1 plus alpha by 2 and this 1 plus alpha by 2, and this P and P can be cut. Now moving forward, we'll just erase this part. Now I can write Kp is equal to alpha. I'm just taking this 1 minus alpha here, 1 minus alpha into alpha by 2 divided by 1 plus alpha by 2 into P whole raised to 1 by 2. So the next simplification step will be 1 minus alpha. I can write this particular as, after taking the LCM and all, I can write it as alpha by 2 plus alpha into P the whole raised to 1 by 2. Now this becomes alpha into alpha raised to 1 by 2 P raised to 1 by 2 divided by 1 minus alpha into 2 plus alpha raised to 1 by 2. So here this particular step will be alpha raised to 1 into alpha raised to 1 by 2. So it will be alpha raised to 3 by 2 into P raised to 1 by 2. And you can see here we are having this particular denominator. First term is 2 plus alpha raised to 1 by 2, 1 minus alpha. I have just rearranged it, right? Nothing more. So here you are getting what is the answer? Kp is equal to alpha raised to 3 by 2 into P raised to 1 by 2 divided by 2 plus alpha raised to 1 by 2 into 1 minus alpha. So your answer is second one. So here a little bit of application of knowledge is necessary and you can easily find out the answer. So be very particular about this particular question, right? Now we will move to the other one. Right. So here it's a very easy question after a bit complex one. In this particular reaction, they have given Kc, equilibrium constant, and they have given a reverse reaction, but they have actually doubled this stoichiometric coefficient. So you know that we are having the relation Kc is equal to 1 by Kc dash, right? You know this particular relation, right? This will be the forward reaction and this will be the backward reaction, and Kc dash is what? The equilibrium constant for backward reaction. And when you are trying to bring a relationship between Kc and Kc dash, what is that? Kc is equal to 1 by Kc dash. Now we will see the forward reaction here. SO3 gas giving you SO2 gas plus half O2 gas, and for this particular reaction Kc is what? Kc is given as 4.9 into 10 raised to minus 2. Now if you write the exact reverse reaction, what will be that? SO2 gas plus half O2 gas giving you SO3 gas. So this is the exact backward reaction, right? And you know that for this particular reaction you will be having Kc dash, right? Kc dash. And what is that Kc dash? 1 by 4.9 into 10 raised to minus 2. But you know that this is not the equation or reaction given in our question. What is that? It is actually 2 SO2 plus O2. That means it's double, right? Half plus half, 1 O2 and 2 SO3. So here the thing is that the stoichiometric coefficient is doubled. So what we have to do? We have to actually raise this Kc dash by 2. That means entire this particular term will be raised to 2. So here you know that it will become 1 by 4.9 the whole square into 10 raised to minus 2 the whole square. So it will be 1 by 4.9 the whole square is 24.1 I guess, and into 10 raised to minus 4. So here what will be the thing? 10 raised to minus 4 I am taking it to the top, 1 0 0 0 divided by 24.1. Right, so here you know that if you divide by 25 it will become 4. So it will be like 400, and you know that it is not 25, it is 24.1. So you know that it will be a value which is close to 400. That means it will be 416, because the only value which is close to 400 is 416. Right, so our answer will be 416. Fine. So this is actually an easy question. Just understand what is that slight difference given in your question. It is not exactly the backward reaction. It is actually the backward reaction with the stoichiometric coefficient doubled. So be careful about that. Right. Now we will move to the next question. Right. The following reaction occurs in the blast furnace where iron ore is reduced to iron metal, and the reaction is given here. Using the Le-Chatelier's principle, predict which one of the following will not disturb the equilibrium. So we are having a chemical reaction and they are actually suggesting some changes. What are they? Addition of CO2, removal of Fe2O3, addition of CO2, removal of CO. And they are asking which of this particular steps or which of this process, removal or addition, will not change equilibrium constant. Can you just think about that? They have actually mentioned about Le-Chatelier's principle also. Can you just think and say? Here we don't want to think much. The reason is that here we are having Fe2O3 as a solid, right? Fe2O3 is a solid, and in equilibrium condition, if you add or reduce a solid reactant or product, there will be no effect on equilibrium, right? So we can say that removal of Fe2O3 will not be causing any disturbance for the equilibrium, right? So addition of or removal of a solid into this particular equilibrium condition will not be, when we are doing that, it will not be disturbing the equilibrium condition. So we can surely say that removal of Fe2O3 will not disturb the equilibrium, right? So it was a very easy question and it was a conceptual question. So just keep it in your mind. When you are adding or removing a solid from equilibrium condition, it will not be changing the equilibrium condition. It has no effect on the equilibrium condition, right? Now we are having the next question. So my dear students, in this particular video we are discussing both the attempts, January as well as April attempt, right? So we have actually gone to the April attempt now. January attempt we had very few questions that we have seen. So just keep it in your mind, right? Now what is the question? Just read the question. At minus 20 degrees Celsius and 1 atm pressure, a cylinder is filled with equal number of H2, I2 and HI molecules for the reaction is given. The Kp for the process is. So here we have to find out the Kp, right? So here let us write the equation once. H2 gas plus I2 gas giving you 2HI. So here, what is the most important thing? It is said that with equal number of H2, I2 and HI, right? The number of molecules of H2, I2 and HI are the same. So I can say NH2 is equal to NI2 equal to NHI, right? This is the most important thing that we have to note down in this particular problem. So in this context, I can write that if the number of molecules are same, right? If the number of molecules of this particular gases are the same, I can write the mole fraction also will be the same. XX2 is equal to XI2 equal to XHI, right? So let it be there. Now we know what is Kp for this particular reaction, right? It is actually the partial pressure of Hi, the whole raised to 2 divided by the partial pressure of H2 into the partial pressure of I2, right? Now I am using the formula that I have used before in another problem. What is that? It is actually the mole fraction into total pressure. That means partial pressure is equal to mole fraction into total pressure. The same formula I am using here. So what is the mole fraction? I know that for HI it is XHI, right? Into what is total pressure? I am just taking it as P, the whole raised to 2 divided by what is the mole fraction of H2, it is X2 into total pressure P into here, yeah, you have to go for the next one. What is I2, right? So for that it is XI2 into P. Now you know that XHI is equal to XH2 plus XHI is equal to XH2 is equal to XI2. So basically all this will become 1, right? Because it is the same. Now at the numerator you have P square and P into P you have P square. So it will become 1, right? It will become 1. So here in this question they have given, we have to write Kp in terms of 10 raised to minus 1. It is also there. It is not included in the slide. So how we can write 1 in the terms of 10 raised to minus 1? I can write 10 into 10 raised to minus 1, right? 10 into 10 raised to minus 1 means what? 1 itself. So my answer is 10. So for this particular question, my answer is 10. So this is also a very good question, a bit complex question and an important model. So take a note of this particular question, right? Now we will move to the next one. Here you may think it as a difficult one after looking this particular reaction and the options, but it's a very simple question. So just go through this particular chemical reaction. What is a chemical reaction? It is carbon monoxide gas giving plus half O2 giving you carbon dioxide, right? Now we know a relation between Kp and Kc, right? What is the question? The ratio of Kp by Kc. That means they are trying us to they want us to make a relationship between Kp and Kc. So what is that relation between Kp and Kc? We know that Kp is equal to Kc into RT raised to delta N. Kp is equal to Kc into RT raised to delta N. Now you see here, what is the delta N or delta Ng? Delta Ng, what is the delta Ng value? Np minus Nr, Np minus Nr. So number of gaseous products 1 minus number of gaseous reactants. So it is 1 plus half. That is what? 3 by 2. 1 minus 3 by 2. You will be having minus 1 by 2. Right. So delta Ng is minus 1 by 2. So I can write Kp is equal to Kc into RT raised to minus 1 by 2. So Kp by Kc ratio. Kp by Kc is equal to what? RT raised to minus 1 by 2. So you just look in this particular option, you can see D is the answer. RT raised to minus 1 by 2. Similar, the same question, the options can be a bit different. Sometimes it will be written as what? Kp by Kc is equal to 1 by root RT. Is it right? Yes. Root denotes 1 by 2. Right. So here it is not 1 by 2, minus 1 by 2. So in denominator, what is the thing? Minus. So in some options, in some cases, when you are referring some text and all, we can see this particular Kp by Kc is equal to 1 by root Rt. That is also the same. Rt raised to minus 1 by 2 is what? 1 by root Rt. So this is also a kind of easy question for you if you know this particular relation, and just apply that particular information given. That means delta Ng value we have to find out, right? Now we will move to the next question. So here you can see they have given certain reversible reactions and equilibrium constant. Now what is the thing? X, Y giving Y giving Z giving W. So they are asking us to find the equilibrium constant for the reaction X to W. So you can understand that basically these all reactions are giving you what? This particular last reaction. It is the addition of these three reactions giving you the last reaction. That means for each reaction you are having a equilibrium constant. If you just take the product of each equilibrium constant, you will be getting the equilibrium constant of the last reaction. Okay, so it's a very simple step. You just take these values. What is K1? 1.0 into 2.0 into what is K3? 4.0. So 1 into 2 into 4. What is that? 8.0. So the K value for this particular X giving you W is actually 8.0. So this is your answer. So what is actually this particular question about? They have given three chemical reactions, three process, and you have to understand this three reactions. The addition of these three reactions is giving you the last one, which is given in the question, X giving you W. So what do you have to do for that? In order to obtain the answer, just take the product of the equilibrium constants of these three reactions, which is given initially, right? And you will be getting the answer for that particular last required reaction. Fine. Now, the last question in this particular section. Here, the question is that the equilibrium is shifted to the right in. So here, you can see this is a dichromate. This is dichromate, right? Cr2. And this is chromate. Okay. So, if you want to change a dichromate to a chromate, we must need a basic medium. That means the second will be the answer. We need a basic medium, right? OH minus is required. If it was the opposite, right? Chromate to dichromate. Chromate to dichromate, you need an acidic medium. Okay, so both this thing you just keep in your mind. So here they have asked the conversion of dichromate to chromate, right? So here in this case we have to have a basic medium, right? So we have come to the end of this particular video session, and you can see that this is a chapter you can score a lot of marks because of the reason, if you just put this particular equations and you substitute the values which is given in the question, it's very easy for you, and you don't have many different kind of questions coming in this particular section. Only few formula and few concepts. If you are very familiar with these concepts, you can easily grab 4 marks. So I suggest you to go through all these questions very carefully and study hard for your upcoming examination. So thank you for watching. Thank you.